These are notes for using logarithms when they are in base 10 form. And so, from some of the video notes that you may have watched last night, y is equal to log x, if and only if 10 to the y equals x. This may seem a little mysterious, so let's label the parts and break this down. When there isn't a number by the log, it is a base 10. It's assumed that's a 10. And the way that you do logs is you take the little base there and you write it first. You take this is the exponent, and it equals this answer here. So basically what's going on is this little number down here is the base. Hold on, let me change. This here, y, if you take a look right there, y is the exponent, and the x is just whatever the answer is. So check it out. Here's the exponent. Here's our base. And here's our answer. So basically, logarithms are used when we want to solve for an exponent. And that is because a logarithm is an exponent. We'll get more of that in the upcoming sections. We're going to learn why logs are amazing. We're going to revisit some old methods. If we have 10 to the x is equal to 450, we have a couple of methods at our disposal, and some are better than others. Brute force was one of the ones we learned, sick. And if we look, x is between what two integers? It's going to be between 2, 10 squared is 100, and 3, which is 1,000. So we're going to narrow this down to get it to one decimal place. Because I don't want to take this all day, I'm going to pause it. I'm going to slowly get these answers done out for you. So let's get it at least narrowed down to one decimal place. We know it's between 2 and 3. We're going to try a variety of things. 10 to the 2.1, 10 to the 2.2. And you're going to find pretty quickly that it works out to be between 10 to the 2.6 and 10 to the 2.7. But those are still way far away from our goal of 450. So you should take a moment, time yourself on this, and narrow it down further so that you get between 60 and 70. What number should it be? Then you're going to narrow it down even further, and you're going to do it all the way down to one last time and get as close as is humanly possible to 450. And then undo the pause button, and let's see what the answers are. Well, you were trying to narrow it down further, and you're going to be between you're looking for numbers between 260 and 270. So we're going to find out that it ends up being between 2.65 and 2.66. 2.66 will give us 457, which is way too far away from 450. And 265 is going to give us 446 point something, which is still too far from 450. So we're going to narrow it down again. So now we're going to be looking between, what numbers between 650 and 660 could we do? And we're going to find that it's between 2.653 and 2.654. Again, these are still too far away from, they're much closer, but they're still not quite as close to 450 as we could be. So we're going to do it one last time, and we're going to find that it's between 2.6532 and 2.6533. And this one here yields 450.09 approximately. This one here is going to kind of yield 449.987, which is like 99. Think about this in terms of money. Which of these two is closer to $450? it's going to be this one. So this is sort of what you would want to do. What are the drawbacks to this method? Well, as we said, it is way too time consuming. And it's not entirely accurate. We still didn't actually find the answer. This is not equal to 450. So what's another method that we learned? You may think back and say graphing. We totally used it on the quiz. So 10 to the x equals 450. We're going to get this by finding the solution to the system. And remember, the solution is just an intersection. Find the solution of the two graphs. And you might say, I don't see two graphs, I see one equation. But if you remember, we're going to do y equals 10 to the x, and then we're also going to do y equals the line 450. So let's take a look at how this is going to play out. We're going to do y equals 10 to the x in our calculator, which is going to be an exponential growth type thing. And we're also going to do y equals the line 450, which is just a horizontal line, like that. And then our job is to find this point. You're going to find out what is x when y equals 450. If you take a moment and enter these two into your graph, you will find that the solution you get, you're going to go and search for the intersection of those two lines. And when we ask it to calculate that, we're going to get that x is approximately 2.6532125, and we know that the numbers keep on going. If you know how to stow it, we're going to do this. There's going to be a whole different video on how to do fancy things in your calculator, which will include this. Now, that wasn't too bad, and it was far less time consuming. When it says, what are some improvements graphing has over the last method? Much less time. And it's also much more accurate. We are going to actually get an answer. But there's an even faster way, and it's just to use logs. If you recall the definition, y equals the log of x, and I sometimes like to write it in a slightly different way, but I'm going to put this 10 in just so that we remember that that's what's going on. This happens, y equals log base 10 of x if and only if 10 to the y equals x. Well, we're going to see what this does for us. So inversely, the log of 10 to the x equals x. And you might think, how is this helping me? There's so much going on. But if you take a look, it looks almost like we canceled something out. So let's just take a quick second to look at our calculator. What is written in the same color as the second button above the log button? It's in the first column of buttons. If you check it out, you should see a 10 to the x. And it's because 10 to whatever number and the log button are actually inverses of each other. It's how you undo stuff. So let's see how this works in an equation and how we can make this look like a really easy problem. You undo an exponent with a base of 10 by taking the log. And that's basically what you do. So what happens is this log 10 crosses that out so that you get whatever the exponent is equal to that. So we're going to go back to this example and we're going to see how it works. First step, take the log of both sides. So I'm going to take the log of 10 to the x. I'm going to take the log of 450. while you guys write that down, I'm going to switch colors. And what happens next is you just cancel. These cancel out. Log of 10 is going to cancel to make this just equal to x on this side. And now we've got x equals the log of 450. And now just use your calculator and witness the miracle. We're going to press log in the first column, 450, and then hit enter and see what comes up. And let me know if it equals this number. That's all you do to get the answer. So try an example 2 on your own. Hit pause and the answer is going to reveal itself. Okay, all you have to do is hit log 3500 and you're going to get that x is approximately 3.544. That is not that bad. So, this is the example from Ms. Ralston's video notes. Let's see how we would solve this. Okay, so step 1 is, since the 10 is already kind of by itself over here, is going to be to take the log of both sides. So when we do that, if you remember, that crosses this part out, and it just gets us the exponent. It undoes all the other stuff that's over there. So we get 2x is going to equal whatever the log of 410 is. Now, don't take that yet in your calculator because it's a bit of a mess when you do it. So let's just say, what would we do to solve for x? We're just going to divide both sides by 2. So now, let's put this entire thing into our calculator. We're going to hit the log button and 450 and close the parentheses. And then do divided by 2. If you don't close the parentheses, it's going to take the log of 450 divided by 2. So it's going to take the log of 225. That is not what we want to do. So remember to close the parentheses. And when we do that, we just get an answer of about 1.3266. So our very last example, and then we can finally be done with these video notes, is what happens when you have something like this, 17 times. So I'm going to turn that x into a multiplication symbol. Times 10 to the x equals 29. What we want to do here is, before we take the log of both sides, we need to get the 10 to the x all alone. You need to isolate your exponent. So we're going to divide by 17 on both sides, and I'm going to get 10 to the x is equal to 29 over 17. It's a gross fraction, but nobody cares. Leave it alone. Same rules apply. We want to undo this 10. We want to get this x free from being in the exponent position. So we're going to take the log of both sides. And when we do that, we just get that x is going to equal the log of whatever 29 divided by 17 is. And there we are with our answer. So you're going to do some homework tonight. I'm going to write it here. It will be posted on the website. And you should bring any questions to me on Tuesday. Don't wait until the A-Day class. Come in case you're having trouble. And good luck.